Hello everyone, good morning. Now today we will start, we will complete the isothermal processes. In the first or second video, I'm not sure. I have taught you about the isothermal process in a simpler way, like basics only I thought. But in this session, we are going to go deep inside the isothermal processes. As that, I'm going to cover like the entire JEE main syllabus, like only theory part. After completing the theory, let's solve some question. I will also post all those questions which I solve in the as YouTube videos, or otherwise I try to make all of them as a PDF and I share in the description. Okay, uh, but I'll mostly try to make a video because I have JEE mains like within some 2 months, no, 1 month. I have no time for that, but yet I'll try my best. Okay, let's go into the topic. It's isothermal processes. Fully we are going to see. Like day after tomorrow, I have isothermal. Like I have this thermodynamics exam test, so I'm just revising with you all guys. Okay, let's go into isothermal processes. As we have seen earlier, what is isothermal processes? In isothermal processes, temperature is constant, so change in temperature is zero, so del T equal to 0. So as we have seen in the first law of thermodynamics, like del U equal to Q plus del U is equal to 0. Why del U equal to 0? Because del U equal to NCV delta T, as we have seen earlier. I hope you remember. Okay, del U equal to NCV delta T, and they have said that delta T is 0 because it is an isothermal process. So if delta T is 0, then in NCV delta T, if I am putting 0 here, then del U is automatically 0, and del H is NCP delta T. See, this is CP, this is CV. Okay, don't confuse with del U and del H. Okay, so and here also we have del T, so del T is 0, so the whole term becomes 0, so delta H change in enthalpy is also 0. Okay, now as we have seen from the first law of thermodynamics, which is del U equal to Q plus W, as del U equal to 0, 0 equal to Q plus W, so Q equal to minus W, or W equal to minus Q. So work done is negative of heat transferred. Okay, now we will be seeing two cases in this. Case 1, as these two cases are nothing but work done is minus Q, like we have defined like this. What is this work? The two cases are just this. Work can be either expansion or compression. Okay, let's consider case 1 as expansion and case 2 as compression. So first we will see about the expansion part. For expansion, as we have said, it is expanding. Some says this is a container, this is expanding, so it is doing a work against the surrounding. And in chemistry we always see in the perspective of the system. So system is doing work. If system is doing work, if I am doing work, my energy is lost, so my work done is negative. Okay, like that you need to understand. So work done is negative. So if work done is negative, then Q is automatically positive, right? So because minus minus will get cancelled, so Q is automatically positive. So system, if Q is positive, then system absorbs the heat, as we have known this, as I have taught you this earlier. Okay, go and check if you are not getting this. Okay, next case 2, in case of compression. In case of compression, what we have seen, in case of compression, say this is that container, this is that piston. In case of compression, the piston is coming down, so surrounding is giving energy to the piston to come down. So the energy in surrounding is transferred into the system. So work done is positive because the system, in perspective of system, it is gaining energy from the surrounding. Okay, so it is gaining some energy, so it is positive work. So if positive work, so if this is positive, then obviously Q is minus W, so Q is negative. This is Q. Okay, don't get confused, this Q here. So Q is negative. If Q is negative, then the what is this, here the system absorbs, so here the system is releasing the heat. That's all. Okay, that's all about this. Now we will be coming to work done. Yes, you need to remember these things. Work done by reversible is always greater than work done by irreversible processes. These are general thing which you should know. And Q absorbed, del, here I am putting mod because Q heat can't be negative, I guess. So yeah, heat can't be negative, so mod is meaningless. Okay, fine, we will put the change the Q absorbed by reversible is more than Q absorbed by reversible. Okay, then you need to remember this thing. There is nothing to teach in that. There is something, but I'll teach you afterwards. Or okay, I'll teach you afterwards those things. Then work done in reversible and irreversible, these are the main thing. These are not that much important, but this is main thing which I'll teach you properly. Okay, don't worry. So if you are feeling like I'm not teaching properly these things, if you are feeling I'm skipping this in, for solving the question, you need to just remember this. And if I have time, I think I'll be having time, so I'll teach you separately. I'll make some video. Okay. If you want, you just ask me in the comments. Okay. So now we will see work done by reversible and irreversible processes. So reversible processes, as we have seen, if we have a container say like this, we are applying pressure slow by slow, like 1 gram, 2 gram, 3 gram, and then the pressure in gas also is slowly reducing. This is known as reversible. So we use integration, because say 1 gram, then 2 gram, then 3 gram, we are adding it in a very small, say 1 gram is say dx, then dx, small dx. So addition can be represented as integration when the quantities are very small, like dx, or here it's dp, because pressure is increasing, right? Yeah. So yeah, work done by reversible is minus p external dv v1 to v2, as we have seen this in the first video. Okay, so if you are watching this directly, you won't understand. First watch the first video. Work done by reversible is minus p external v1 to v2, so minus integration v1 to v2. As we know, pv equal to nrt, so if pv equal to nrt, p is nrt by v, so I just substituted directly. So and then I'm putting this dv here, minus sign as it is, and v1 and v2 here. So nrt, all these were constant, so I am taking all this out. So integration of I'll be having dv by d. As we know that integration of dx by x is ln x, as we have studied in integration. If you are not studied, please go and do integration class 12. uh, Probably this chapter is in 11th, and if you are saying I don't know integration, learn integration of 12th completely. It's highly useful for solving many questions, like in chemical kinetics also you have many things related to this. So without basic math you can do nothing in chemistry or physics. Okay, you need to know. If I'm saying integration of dx by x, you need to say it's ln x. Similarly, we are taking nrt outside, so it is integration dv by v, that it is x, here it is v. So integration of dv by v is ln v, and ln v we are putting limits from v2 to v1, so ln v2 minus ln v1. Okay, and you also need to know the properties of logarithm to you solve this. And the properties of logarithm says that ln a minus ln b equal to ln a by b. So here we have got ln v2 minus ln v1. So ln v2 minus ln v1, which is log a minus log b, is log a by b. So ln v2 minus ln v1 is ln v2 by v1. That's it. Okay, so minus nrt ln v2 by v1 is equal to here I am putting minus nrt ln p1 by p2, because in Boyle's law, as we have said, this is isothermal processes, so del T is constant. So del T is 0, T is constant. As we know, PV equal to nRT. If temperature is constant and N and R are already constant, then PV is constant. If PV is constant, P is inversely proportional to V, because if PV equal to constant, then P equal to constant divided by B. So these are inversely proportional, right? So if A is inversely proportional to B, then A1 by A2 equal to B1 by B2. I think you would know this. So similarly, V2 by V1 is P1 by P2, just the opposite of this. Okay, so minus nRT ln V2 by V1 equal to minus nRT ln P1 by P2. That's all. Like, you can either use this or either use this to solve a question. If you are given pressure and asked to find work done, you use this thing. If you are given in terms of volume, use this. That's it. Okay, so yeah, you can use. And yeah, one more thing, ln x can be converted to log x by multiplying log because 2.303 into log x is ln x. Okay, you need to remember this thing, or you need to know this thing. These all were basics of integration in class 12. Okay, you need. If you are saying I don't know nothing of this, then you probably watch all those and then come here. Okay, yeah, that's it for today's video. I feel tired. Okay, I want to sleep. Okay, bye. Okay, bye.